Ma'am, we'll start, ma'am. Crossed 50 plus participants. We'll start now, shall we? Ma'am, sir.
Yeah, I'm fine,
Yes.
Krishna.
Okay. Dear participants, uh, today we are in the fifth day and session number 9. So we have Dr. Senthil Rajendran, country head, RMSI Middle East Limited. So I would like to welcome him for this presentation, particularly because on behalf of Department of Civil Engineering, SRM Madurai. And I would like to introduce the resource person to you. Just Oh, so sorry, my connection is not stable. Now I'm okay. Am I audible to you, ma'am?
Yes, you are audible, Krishna Kumar.
Okay, okay. So I would like to introduce the chief guest, a seasoned geospatial and land administrator leader with more than 20 years of experience working across various countries like Europe, Latin America, Central America, the Caribbean, Middle East, and Asia. He has developed a unique combination of technical proficiency and program leadership, delivering modernization of land registries, national mapping agencies, digital land administration, and national-wide geospatial transformation programs. He currently leads several active World Bank financed projects underway in Georgia, St. Lucia, St. Vincent, etc., advising government leaders and cadastral reform, geospatial enablement, and modernization of institutions besides others also. He is also RMSI head of business of the Middle East, where he has implemented missions critical projects for national mapping agencies, real estate regulatory bodies, and land registries to support their nationwide development plans. His experience is some of the Middle East region's most ambitious urban and infrastructure development projects, including mega projects such as NEOM and Kudia, is worth mentioning here. Across his career, Dr. Senthil has recognized for his capacity to turn data geospatial and learned into trusted national systems that are ready for investment and can be used to support policy, drive development, and fuel economics. He is a unique ability. He has a unique ability to connect the dots between technology, policy, and street level execution. Today, learning or transforming our city's infrastructure and decision making at scale. And his example will be drawn for live projects on ground right now, not the theoretical studies. So, with this brief introduction, I would like to welcome Dr. Senthil, sir, for this session. Sir, I welcome you, sir, and the session is over to you.
Yeah. Thank you, Krishna Kumar, and thank you, SRM Madurai, and Dr. Gauri, and the head of the department, and Krishna Kumar, who have been coordinating with me for this lecture. Welcome. I'd like to welcome all the participants. Yes. So let me share my screen so that we can get started with the presentation. Please let me know when you are able to see my screen.
Sir, it's okay, sir. It's visible, sir.
Full screen. You're able to see full screen. Is it
Yes, yes,
visible to
full screen.
everyone?
It's in full screen
Right.
mode.
Okay. The today topic that is given is AI, artificial intelligence, and Internet of Things (IoT) for resilient infrastructure and advanced disaster management. So I also learned about the participants who are attending today. There are participants from civil engineering stream, computer science, and other similar backgrounds. So I appreciate very multidisciplinary team members today focusing on this AI and IoT implementation for infrastructure management and especially in management context. So the agenda for today's meeting will go like this. It's Let's touch about the India's disaster risk profile first. Why artificial intelligence and IoT are needed in the first place. Then what is resilient infrastructure? What does a resilient infrastructure mean? Then role of IoT in disaster management. Then how IoT use cases have been built in India, Internet of Things use cases. Then about the digital infrastructure backbone that is essential, the most essential for such kind of implementations. Then we'll slowly move into the smart cities and urban resilience, which is the topic of this presentation. And then what are the governance framework that currently we have in India? And one of the platform, I would say, it's called RMSI's NatCat Impact Platform. That we'll see how it is built and how it helps. Then, what should be the roadmap and the strategic vision of disaster management agencies to combat such kind of disasters? Then we will see so many international examples of IoT and AI usage, mainly for managing the cities, managing the disasters, and so on. Starting with the India's disaster risk profile, almost 59% of the landmass of India is prone for earthquake. So say about 60% of the India's landmass is prone for the earthquake, and close to around 12%, that's 40 million hectares, are prone for flooding. For This is a very alarming rate number. Apart from this, there are cyclones, droughts, heat waves, which are on the increasing trend, and mostly it is not predictable, which is on a increasing trend. And also, the climate change is amplifying the risks, like flash floods and drought and cyclones. All these are amplifying the risks for property damage to the lives and property. But and why artificial intelligence and Internet of Things have been even chosen as one of the savior of this kind of disasters, or why do we think that these technologies can even help in mitigating these problems? Because the traditional reactive response, you can say, it is almost not helping us, or it is insufficient. In most of the cases, it is the traditional reactive response is insufficient for us to address the impact of disasters. So that is where there is a need to predict what is coming. So the predictive and real-time systems, like how when we can predict in a much better way, either by early warning and also by the real-time systems, we can collect large amount of data that can be used to see the trend and see what's coming in advance. Then the third one is about the data driven decision making. Like all the planning needs large amount of data, and decisions has to be made based on the data that is available with us, not a random decision is made on development planning. So these kind of technologies, artificial intelligence and IoT, they help us collect and collate large amount of data, and the decision making is purely scientific based on the data that is analyzed. With this, an automated early warning system is very easily built, that is acting as one of the savior for governments across the globe, and India is not an exclusion for it. So that's the reason why AI and IoT are needed for this kind of disaster mitigation efforts. And what is a resilient infrastructure? Because this word is picking up a lot of importance in the recent times. From sustainable development to now, it's more like a resilient development, resilient cities, resilient urban planning programs, and so on. So the resilient infrastructure is something which anticipates the risk, what might come or what is going to come. It could be an event, it could be a flood event, or it could be any other disaster event. And to some extent, or to a large extent, it absorbs the shock. It is designed in a such a way that it can absorb the shock to some extent, adapts to the threats. Like it also adapts to the threats like multi disaster hazards. So that is one thing. And the most important thing of a resilient infrastructure is the comeback period. It recovers quickly from the effects of the disaster. So that is the most important point in the resilient infrastructure. So the role of IoT, Internet of Things, is the real-time sensing. Like large amount of sensors are now it comes for a very negligible cost, and it's very affordable, and it can be integrated with the multiple different applications. It's very interoperable. So such kind of facilities have made this very popular among the solution developers. So the real-time sensing is very much possible in almost all the fields now. And continuous monitoring, whether it is a CC camera or whether it is a weather station, air quality monitoring, anything, the sensors work 24/7, providing continuous data supply and continuous monitoring of a particular location. Then also it has the with the advent of all this communication technologies, it is able to send automated alerts for after monitoring. And also the cloud computing and the edge computing, this has given a lot of advantage for analysis, quick analysis. That is important. The most important thing is quick analysis of large volume of data to make the right kind of decision. So the most popular use cases in India for IoT is mainly for flood and river monitoring, landslide detection, then cyclone tracking, heat wave tracking, heat wave prediction, and air quality monitoring. These are very basic use cases, and some of the most effective use cases also in applications in India. Role of artificial intelligence in disaster risk reduction is once again the predictive analysis with the large amount of data that is coming in from the real-time sensors. Then it recognize the patterns, like pattern recognition, which is there, which is one of the key outcome of this analysis using the AI algorithms. That helps prevent, or that helps the right kind of taking right kind of action for most of the disaster management programs. Third one is the simulation and modeling. Like, what if there is a extreme event in this particular locality, and which are all the other areas that will be affected? This kind of simulation modeling, whether it's related to hydrology or traffic or any other systems. Then resource optimization, whether it is a human resource or a material resource, optimization is optimizing the resources is possible using this kind of artificial intelligence technologies. Then the damage assessment, pre and post event analysis, that helps governments plan well ahead for handling disasters. Some of the AI use cases in India is mainly the flood forecasting, infrastructure health monitoring, whether it is railway bridges or road bridges or any other uh, physical infrastructure of the government. Then the satellite disaster mapping. So this has now become routine work. Like the governments, state and the central government have got plans around updating their maps, mainly which helps during the time of disaster for mitigation measures. Then the drone-based damage analysis, like with the drone technologies, it is very handy. Even within a few minutes, the surveys can be done, and then analysis can be damage assessment can be done. Then logistics, emergency logistics also, drone technology comes in very handy for delivering of emergency logistics and so on. Yes. So, as I already said, for all this to happen in a country, so there has to be some kind of an digital infrastructure that will serve as the backbone for building this kind of applications. Like, for example, some of the infrastructure here, digital infrastructure in India has been mentioned here. One is Aadhaar for authentication of the persons. Then DigiLocker. DigiLocker is another authentic service infrastructure, which is backbone of the country. UPI is another payment services, another backbone for the country. Then ISRO, Indian Space Research Organization, has got many programs for Earth observations. So that certainly adds a lot of value, and that's more. In fact, that's the core part of most of the developmental and disaster mitigation programs. The National Disaster Management Agency has got platforms. One such platform I'm going to explain in the next few slides. So these are some of the digital infrastructure which acts as the backbone for building more and more such kind of applications in the country. Coming to smart cities and urban resilience, these the following points mentioned here, these acts as some of the prerequisites, like integrated command and control centers. Like, how do you manage how do you call a city as a smart city or an urban area which has a very good resilience? First and foremost is you need to have an integrated command and control center with all the tools and technologies possible in order to efficiently manage it. So that is one requirement. Next is the network of sensors, whether it is IoT sensor or camera feeds or any kind of sensor. There are plenty of sensors that are at work, air quality monitoring sensors, temperature, pressure, everything. So as network of sensors are needed in an urban area or in a city in order to monitor it efficiently. Then AI traffic systems. So most of the now the cameras that are getting installed in the cities are AI enabled. So the automatic challan systems, everything is now automated. So this is another important uh, network of infrastructure that is needed for a smart city. Then emergency response coordination. This coordination needs to connect with all the sensors and cull out all the data from this, which will be integrated, which will be coordinated by this integrated command and control centers. So these are only a few pointers that are given here as a prerequisites for a smart city. Coming to the governance framework, a country which is poised to make this AI and IoT IoT as the core part of their solutions, whether it is for disaster or urban planning, then they have to have a governance framework. Like, how do they govern? How do they have a governance framework under which all this can be brought in, plans can be made, and implementation can be rolled out? So here in India, it is National Disaster Management Agency, State Disaster Management Agency, then NDRF, then IMD, Meteorology Department has got a lot of tools and network. Then Central Water Commission. Then for Ocean Information System also, there is an organization. plus ISRO. So these are all the organizations which forms part of this governance framework, whether it is planning for a initiative or whether it is for data sharing between different organizations. Everything comes under this governance framework, and these organizations work has to work hand in hand in order for this kind of applications and this kind of use cases to be successful. So, challenges that we are currently facing in order to move from the conventional system onto such kind of AI enabled systems are: one is the legacy infrastructure. Most of the infrastructures are dated, are a bit old and outdated. We are in the process of building them, rebuilding them continuously. Then the data silos. This is the biggest threat, because the data is not available in a format it has to be it is needed in order to use. Then the data silos, like it is not shared between the organizations. Most of the data is stored in the PCs of the departments, like the computers of the departments or the databases of the departments, which does not have connectivity to a to some of the key systems. Then connectivity is also another gap, whether it is internet connectivity or connectivity of network of sensors. Many type of connectivity at all levels is certainly a gap. Then cyber security risk. So recent times you all might have seen like how a cyber security hack can jeopardize a country itself, like a country how prone it is for completely stopping the functioning of a country itself. So cybersecurity risk, we have to protect most of the data, everything, systems are against this kind of cybersecurity risks. Skills shortage is certainly a very important point, like to focus on upskilling from the conventional to the latest technologies like AI and IoT. With this, I'm moving to the next topic. Is everyone fine with you? Have any questions, or we can move to the next section of this presentation? Krishna Kumar, all well?
Yes, sir. Going fine, sir. Participants, if you have any questions, you can ask now. Till sir, we can go ahead. I think there is no questions. We can
Okay,
go
thank
ahead.
you. Thank you. So I'm from a private sector, one of the uh, geospatial solutions providing company, uh, which is 30 years old. It's based out of India, Noida, and we have a product called Sirenex. So this is like a 24/7 live global NatCat impact platform. So any event can be traced here. Mainly to understand the impact of every upcoming natural calamity well in advance, at least 2 to 3 days in advance. So this kind of products will potentially help the disaster events and or for organizations to plan the mitigation efforts and to reduce the damage that is going to be caused by this event. So here, some of the functionalities, like you can visualize and analyze the impact of the upcoming event, whether it could be a flood or it could be a hurricane, so that you can take uh, you can have actionable insights and you can take the mitigation measures. So this is an AI-enabled multi-hazard impact forecasting for with it's a SaaS platform, software as a service platform, which can be subscribed by any private and government agencies for their businesses, and it covers both flash flood and riverine floods. cyclones, typhoons, hurricanes, fire, earthquake, and landslides are also available. Then, as I said, it gives alert to the users at least 2 to 3 days in advance, and to implement the mitigation measures which can reduce the impact drastically. And it supports the integration into client systems as well through APIs. You can just extend it through an API, and it provides a detailed weather parameters in advance. So it is connected to the real time weather data, which will be helpful as well. So this is how it works. Like it geocodes your location of interest, sets up an alert mechanism for the stakeholders, and it creates a hazard map for any live event. You know that, like between Tamil Nadu and Andhra, there is going to be a cyclone or something which is going to cross. So you can create an you can you can create the location of area of interest, and then set an alert for this. Plus, you can also create the hazard maps for any live events. Also assess what would be the impact in case if this is the track in which the cyclone is going to travel. And also it can send out alerts for all the organizations online, and visualization of the impact, or how badly it can affect, and you can just visualize it in a dashboard. Who uses this kind of For whom this kind of platform is useful is mainly for the insurance reinsurance brokers, for utility companies, whether it's power, electric, power, or communication uh, organizations, and for other FMCG and logistics and other organizations which is going to be affected badly because of this kind of event. So any business user can be uh, benefited out of this kind of platform. Also, it has got international acclaim from several international organizations, as well as in US media, for this product. So this is one of the impact platform that is available even for uh, Indian geography. Coming to the future roadmap, so what should be the approach of this kind of national disaster management organizations, or any organization that wants to approach mitigation solutions for disasters? First and foremost is then they should have a national sensor grid. So that is going to collect all millions and millions of data, and provide at the right time for first understanding the event well in advance, and also quantifying the impact, and taking the right kind of mitigation measures. Second is, like, cities can go for something which you might be heard you might have heard in the recent times, is digital twin. So digital twin is just a electronic twin of a particular city or a particular building. It could be anything. So which is an electronic copy of the real building itself, or the real city itself. So the advantage of a digital twin is, like, you can monitor, and you can model many things which is not possible in the real life scenario. Then predictive maintenance. So the digital twin also is used largely for predictive maintenance of the buildings of infrastructure. It could be road infrastructure, bridges, and so on. Then autonomous disaster response. So once you are able to model it, and once you are able to monitor it, then automatically the third one is autonomous response, also for such kind of disaster also can be planned. So this is one of the direction in which this disaster management organizations have to think about. And their strategic vision for this kind of organizations could be from reactive relief to predictive resilience. So currently, or conventionally, their objective is to provide a reactive relief. From there, they can move to a predictive resilience, which will help monetarily, which will benefit monetarily and also avoid loss of life and hardships to people. Then AI driven national disaster resilience platform, this is inevitable in the coming days. Every single disaster management agency must think about AI, having an AI driven national disaster resilience platform. Okay, now with this, the second part of the presentation is over. I'm now going to move on to the international examples of artificial intelligence and IoT for resilient infrastructure and disaster management. So, if there are any questions still here, I'm happy to take it.
Participants, if you have any questions here, you can ask now.
Uh, Professor,
Yes, madam.
like with respect to the Indian scenario, do we have the real-time monitoring of such activities, whatever you have described so far, for the urban infrastructure development?
Yes, there are available, but not in a very large scale, and for not for all the cities. So maybe for some of the major cities like Delhi, Mumbai, and also major flood prone areas or disaster prone areas, they may have such kind of facility. They are having such kind of facilities, but it is not rolled out to a country level.
Because in our regional planning, now we undertake the smart city developments. Like, do the smart city developments incorporate all these resilient infrastructure?
They aspire to incorporate all these things, but how much of it at the time of implementation, how much of it is implemented, that is still under question. But yes, they aspire to have such kind of solutions at the time of planning itself.
Fine, sir. Dear
Some of
participants,
the that's where I will touch upon some of the large private urban development plans internationally, how
okay.
proactive they are in planning for such kind of AI based infrastructures, while they come up with the planning itself, like large cities to the tune of more than 100 square kilometer, 200 square kilometer, brand new city. It's a green field development, how they
Mm.
are planning for such kind of AI based facilities, AI based applications for disaster management and infrastructure management mainly.
Okay, sir. Participants, if you have any queries, you can just unmute and ask the queries, or you can drop it to the chat box also.
Yeah, any queries you can drop in the chat as well if you don't want to ask now. That's fine. So let me continue with the international examples. So this is everyone knows that Netherlands or the Dutch is one of the country which is advanced in terms of geospatial technology, utilization of geospatial technology, artificial intelligence, and IoT technology for each and every industry, whether it is for transport, whether it is for water management, or yeah, every walk of life. They try to utilize this kind of latest technologies, build applications that can help them. So this is one example where Dutch Authority for Water Systems, RIG Waterstat, it's using AI to analyze the data from thousands of sensors, the network that they are having, mainly for water levels, to monitor the water levels. Everyone knows Netherlands is like below the sea level, and they are prone for flooding. So mainly to monitor the water levels, infrastructure integrities. They have huge network of dikes, sluices, bridges, because they are literally underwater. So they need to have this kind of facilities, infrastructures like dikes, sluices, and bridges to maintain and manage the water flow. So these kind of they have a huge network of monitoring sensors. So for all this are connected to this AI systems, and they keep monitoring on a continuous basis. So this helps them to detect anomalies early. If there is something wrong in those hundreds of dikes and bridges network, if something is not correct, if the data is not uh, reading properly, then they can alert the organizations and or the officers well in time, well ahead of time, to take actions. So whether it could be like for flood forecasting and or for infrastructure resilience. So they have a program, AI supported water movement model. It's called Impulse Programmer, AI Impulse Programmer, under which this combines a machine learning with the traditional hydrodynamic models. So hydrodynamic models are the world number one, or they are the authority for hydrodynamic models in the world, and they combine this with the machine learning to produce more accurate results, quicker results, especially about the forecast and the river and the sea behavior. So literally, they know on they track everything on a real time basis, and the decision making is also on the real time basis during the emergencies with this large amount of data that they collect. Then this is another use case where the flood barrier control using artificial intelligence. You must have seen this picture where they have huge flood barriers control. Like it's like a gate which gets automatically closed. There are no persons operating that. These are all automated gates. Depending on the level of water, it automatically protects the city, whether it has to, how much of water it has to allow, and the remaining is just closed. As I said, the Netherlands is very vulnerable to flooding due to its low-lying geography, and these technologies are built mainly for water management, coastal protection, and infrastructure resilience. This helps to predict, monitor, and respond to disasters, and enhance the overall resilience of the cities like Rotterdam and other cities. That's why Dutch Ministry of Infrastructure and Water Management is able to efficiently manage those cities and country itself. So another important challenge for them is the maintenance of this kind of infrastructure, bridges, locks, viaducts. So most of these infrastructure were built in 1950s and 60s, and it needs continuous repairs, replacement of the components, and most of the infrastructure would have come to the end of its lifespan. So how do they keep track of all those things? Is using this network of monitoring sensors. Where it could be cameras, or it could be others IoT sensors fitted on top of this infrastructures. So the last point you can see, AI is also providing a concrete solutions with the drawings, like viaduct drawings. They have in hundreds of numbers. So these are digitized, and then these are put in a database, and using their AI function, this detects like which particular viaducts are due for maintenance, and when it has to be replaced or repaired. So even for this, they need a lot of manpower, which they do not have, and AI functions help them with this kind of analysis that saves tremendous amount of time as well as manpower. So because unlike in India, they don't have the liberty to use thousands of people for their running the government efficiently. So that's where AI function and IoT sensors are efficiently used for this kind of applications. And in the police, which is one of the another subsystem of an urban system, that is security, safety, and security. So Dutch police also has a lot of applications that are developed around artificial intelligence, using artificial intelligence technologies, mainly to recognize the patterns. Like one easiest example is image, like face recognition, then tracking down the producers of any unwanted thing, then warning people about the new form of frauds, like how it is happening. That is dissemination of the information quickly to the public so that they don't fall prey to that. Making large files searchable more quickly, like already most of the law enforcement agencies, they have moved very quickly on AI, utilizing AI technologies, mainly for identifying the right pictures and everything. Identifying suspicious vehicles through LPR, license plate readers, have come in very handy for monitor this thing for monitoring of the vehicles which is flouting the laws. Then protecting privacy of sensitive data, like sensitive data when it is sent out or sent in to the country, it is filtered and then it is quarantined and without causing any damage to the system. And analyzing complex data streams as well, like there's a huge amount of social media data that is going in and out. So this has to be monitored. For everything they are utilizing this kind of applications that are built on AI. So some of the IoT examples, Internet of Thing examples, is like using drones and AI for forest fire detection. Institute of Public Safety, Netherlands, uses drones because they have a season where during which they get the forest fires, so or wildfires. So during this season or well before this season, they start operating this drones for sorties so that they can keep monitoring for any kind of fire incident which will not spread. They can take immediate action that will not spread and cause large scale damage to the entire forest or entire crop. So, especially between late March and October, these aircrafts or these drones are operated continuously by the organizations, and then they can monitor it and avoid large scale damage to the crops. Then e-call is one of the very popular you get service, mainly for emergency. Whenever a vehicle gets into accident, by default, it calls the emergency services, even without the driver intervening. If the driver is not affected, then there is a special button also provided on the dashboard, which can be utilized for calling the emergency services. But even otherwise also, if the driver is not able to react, then also the call is made automatically to the emergency services based on the impact, and it transfers the location of the vehicle to the emergency services, ambulance and the police services. This is how the emergency e-call system works. Then environmental zone enforcement using ANPR camera. Uh, so you must have seen this kind of ANPR systems have come in the police vehicles, what they use for their regular sorties. So Amsterdam is also using this kind of ANPR system, where along with the cameras, there are other equipments, license plate readers, and it's connected to the database, whether it is for any compliance related database related to vehicle, related to licensing, or related to crime database. A criminal may be escaping in a car, and then to identify that particular criminal, even his picture, his face is photographed, and then it is quickly cross-checked, verified, to ensure that he is the person to be caught. So all this kind of facilities have come in handy within the vehicle, police vehicle itself, so that helps them to speed up the enforcement. And another thing is environmental zones. Like unlike many countries, they have very strict environmental pollution. That's emission zones. They call it as emission zones on a particular road. Just to keep the emission under control, you are not supposed to operate the vehicles or operate the cars between this time and this time. So, by chance, any car which is having a emission level more than more than the stipulated one is passing through that particular road, then it will be fined. So, such kind of facilities are designed and they are enforcing as well in Netherlands. So this is the vehicle that you can see, which is fitted with all this LPR scanners and other camera, everything in a single unit. It can also see whether the street is clean or is there any trash lying outside of that disposal zone, and what is the status of the street lights, whether it is well lit, illuminated or not. So it can be used for many applications, and it is being used for many applications as well. So another real-time traffic management system that the Dutch Highways Department has got, National Road Traffic Data Portal. This is a very vast network of physical sensors that to monitor the flow of traffic. Close to around 25,000 sensors are located along the arterial roads and highways, and it has inductive loops as well. Like 14,000 loops are embedded in the motorways, which keeps counting the vehicles, number of axles moved around it, moved on it, and so on. Plus also the specialized systems like weight and motion sensors. Like it can also weigh if the vehicle is uh, overloaded, if it is crossing the permitted weight levels. That also is monitored through this weight and motion sensors. And how this traffic data is used is for mainly for traffic management, for public information, which stretch of road is overcrowded, how much delay is there in traffic, so that what is the alternative route that is available, and for historic analysis of particular a stretch of road may be continuously crowded from morning to evening, irrespective of whether it is a peak hour or non-peak. So such kind of historical analysis can be done, and any mitigation measures like additional flyovers to be constructed, or what is needed, what the strategy is needed to decongest that particular road. And safety and compliance is another area where this data is used largely. Then comes the real-time groundwater monitoring using IoT sensors. Um, Netherlands have got a very unique register called base register for subsurface data. Like how we have land registry, we are registering our land. Similarly, each and every underground asset is also having a register called as a base register for subsurface data in Netherlands, and everything has to be recorded. Here, I'll show you how the system is. Okay, I'll come to that. So this. register collects data on subsurface, including the groundwater monitoring for wells, uh, and other. It is also using other IoT technologies such as telemetry, and enable crucial and fast updates so that the real time data is utilized it for the purpose why it is intended for. So this is one another application which is being used by the base register for subsurface data. And like this, many water management applications, case studies have been developed by Dutch government. This is for IoT platform, which port of Rotterdam, because they have a very busy shipping routes as well. Port which is utilized for both ships for material transport as well as for cruise ships for people transportation. So they have mainly come up with this kind of Internet of Thing platform for monitoring the ship traffic and for planning the ship traffic and movement of the ships safely to pass the region. So what these IoT sensors are monitoring is the data on water levels, currents, salinity, wind speed, wind direction, and the visibility. So these are all some of the parameters that these IoT sensors are monitoring, reported back to the central office, and this kind of planning, this kind of data helps for planning of the movement of ships and other cruises. Then for in an urban area for garbage management. So when a garbage bin is almost going to be full, the IoT sensors are monitoring continuously and then alerts the solid waste management authorities for removal of the waste so that it can hold more capacity and the city would be more cleaner. So such kind of smart bin applications, which is IoT driven, uh, is very much in use. Yeah, this is you must have, for someone who has traveled to countries like Dubai, you can see that like when you get a visa in the immigration itself, they'll also give you a free SIM card. So why do you think they are providing you with this free SIM card? Because they track the movement of that particular tourist. How, what is the pattern, like which is the most visited place of this tourist. So plus they also track the Twitter, Facebook posts and everything, so that they get to know the pattern, your choice of interested places. Then what is the mode in which you are moving, whether you're taking a metro or you're taking taxis or you prefer to walk. So every activity is being tracked, and then the city at the time of city planning or at the time of any project planning, they take all this data into consideration for and this data, the millions and millions of data is there, which has to be processed using such kind of AI applications. They call it as a living lab that they have for in Europe. So it encompasses everything. Data is collected about the nightlife crowd. Data is collected about how the traffic, working traffic, moves during the daytime, during peak hours, non-peak hours. Every activity is monitored and modeled. Well, so this is another interesting and most important what to say solution that the Middle Eastern countries need. For example, you must have heard of sandstorms. Like in India, you must have seen some gusts, small gusts, which is not a sandstorm, which doesn't affect large cities for days together or weeks together. Maybe it's a small phenomena which lasts for a few hours or few minutes. That's it. But in case of Middle East, like deserts like Annafad or deserts like Rabal Khali, which is in which runs from Saudi Arabia all the way to Oman. It's a very large stretch of desert, and huge amount of sandstorms are originated here. And it does not only affect the local that particular country, but it keeps traveling to neighboring countries like Kuwait, Iran, Iraq, Qatar, Bahrain. So many countries it travels, affecting visibility, spoiling the health of young and the old, respiratory problems. So many. It attributes to so many problems. So this is just an experimental this thing, national sandstorm intelligence platform, because they need to know where it is originating. They need to know how it is traveling, in which direction, east, west, north, or south. And they need to know how fast it is traveling. Is it going to come reach to the next country today or after 2 days? And how much load of sand is on the air, and what is going to be the visibility that they are going to get, whether it is only a few meter visibility is going to be there, or few hundred meters of visibility is going to be there. How they should plan for movement of movement of this thing, air service and so on. Whether they have to close the airports. So many things needs to be there. So here, national risk like health could be one of the risk, and road accidents could be another. Flight disruptions, power outages, so many things they need to plan well in advance. And what it predicts, this kind of application will predict is AI and IoT prediction is dust on tracking and health impact zones, which all zones will be worstly affected, and road visibility alerts, which are all the stretches. It could be there could be some highway which will be very seriously affected. Uh, then energy and water risks, like which pylons will be affected, or which networks will be disconnected, and so on. And smart warnings through all the medium, emergency alerts through mobile phones, school closures to be planned, traffic advisories to be given, and workplace safety to be ensured. So at the end of the day, this what does this kind of solution, how does it benefit the government is what you see at the bottom. 40% reduction in the accidents could be one of their objective, and it would have helped 35% hospital cases, reduction in 35% of hospital cases compared to the previous year similar event, and 30% reduction in the power failures. So this is what is the contributes to the millions of dollars saved by the government in their planning activities. So this is the true benefit of having a solution that is AI and IoT driven for this kind of disaster management program. So I have just given one small example of only a particular event, sandstorm. Similar thing you can imagine, like for floods, there could be so many types of solutions that can be that can be prepared for landslides and so on. Any questions still here? Because I'm going to, Krishna Kumar, are we doing good on time?
Yes, sir. We have time up to 7:30, sir. No problem.
So
Another 30 minutes.
30 minutes more.
Right, okay. So if there are any questions still here, I'd be happy to take. Otherwise, I'll move to the next topic, digital twins.
Sir, what are the difficulties India is facing, sir, to adopt these kind of AI tools in India? What are the practical difficulties we have?
Yeah, I had one slide on that topic. Let me just go back to that and show that topic. Show that slide. Yes, this is the slide. The challenges is mainly the legacy infrastructure, because most of the infrastructure, physical infrastructure we have are a bit outdated. It cannot, most of the infrastructure cannot be retrofitted as well, like with all this kind of sensors and technology, advanced technology related stuff. Second is the data. One is the data collection. Second is the data which is available already, that is needed for such kind of trend analysis, and everything is available in silos. There is no data sharing that is taking place between a state and a central government organization, or a local and a state government organization. So this kind of challenges are there, definitely. Third one is the connectivity in at all levels. It could be internet connectivity, it could be um, other working in tandem with uh, different departments and different levels of government, local to state to central. All this, there is a gap in this. Then comes the cyber security risks. Like we are still not 100% resilient towards cyber security attacks and other things. Last one is the skill shortage. Like who's I mean, the government can make plans. They can make the programs, like so many program, national level programs, state level programs. But when it comes to implementation and success of the programs, what plays an important role is the skilled uh, set of people to implement it. So if there is a shortage of such kind of skilled employees, or skilled technicians for building the systems, for maintaining and managing and maintaining of the system, has to be very clearly done. Otherwise, everything falls flat. Have I answered your question, Krishna?
Yes, sir. I have one more doubt, sir. Whether other countries, I hope these things are common for all the countries. Maybe every country will have legacy infrastructures, those things. But India is marching towards that. I know, I believe that.
Yeah.
But whether all the countries have achieved all these things, whether you are
No.
beyond that.
See, that's why I took an example of Netherlands, because they are always very much poised towards utilizing technology for their day-to-day life. But you're correct. Even in Europe, most of the other countries would not be even at the level where India is today. So not all the countries are at the same level. Once they are affected by floods or any other disasters, they are suffering much more. That's the reason I have taken the Netherlands, because the Dutch design, like they are the number one, and they are the authority in water management, and they are the one who have set most of the water management practices across the globe. So they are a bit advanced in terms of utilizing technologies, not only to water but to all the fields. And countries in Middle East, they always want to have the best of the best in terms of technology and solutions. So the reason could be, one is there is no an order is issued and it has to be done, is done. No sir, nobody can go to court, or nobody can have a second thought about it. No discussions whether we can implement it or not, nothing. They decide and make it as a, they only issue a decree. They make it as a rule to be implemented and followed. That's it. End of the story. Yeah, there are challenges in all these countries. Some countries overcome that by the way they handle the policy, how they make it possible through policies and strategies, and some are still trying to do it in a very democratic way, and they are a bit slow in that. But every country has the same kind of challenges, so it's up to them. Some of them are able to overcome quickly, some of them a bit late.
Okay.
Sir, like you said, that the developed countries are monitoring all these by using their big data analytics or AI or some kind of technology. And when it comes to some disaster, why are they not able to predict the disaster and at least give some precautionary measures to stay away from that or be prepared to face the disasters?
Yeah. See, it's not that one thing is for sure. It's not that all the disasters are 100% predictable, and it doesn't affect that particular country. Suppose a country has predicted it, yes, this is disaster is coming to us, and it's going to come exactly in the next 2 days or 3 days, whatever it is. But still, after predicting also, after the disaster has happened, what is our mindset in order to come out of that of that situation? So in such kind of cases, like the resilience in India is like way higher than most of the other countries, whether it's in Europe or in North America. Like the people take the initiatives of building it back or bringing it back. So such kind of initiatives, I think India is way ahead in such kind of a mindset. But some countries are totally dependent on the government machinery to set everything back to normal. So those countries could be very small, or the people, the age pyramid maybe may not permit that, because most of the people will be more than 60 years old. The younger crowd may not. There may be very less young people to bring the city back to how it was. So many factors affects this one. There is no one single rule that yes, this, if we have all this mechanism in one country for monitoring of this kind of disasters, that will bounce back very quick. No, there's no golden rule for it. That's what is my opinion.
That is the beauty of India, sir. Like we have the dynamism within the entire extent, geographical extent. Like even though we have so much of good advanced technologies, people get involved in such critical situation and bring everything back to the normal.
Exactly, that's true. Can we move on to the next topic, the last topic, digital twins?
Yes, sir, we can, sir.
Okay. So here, once again, I'm touching upon some of the case studies of a digital twin of Netherlands. They have something called as a living digital twin. So the reason I'm giving all the links here is for you to so that you can go. It's not possible for me to show everything here. Whenever you have time, you can just go through these URL and then find about more about how this living digital twin has been developed. What is it used for? Is it used for asset life cycle? It's used for underground asset management and so on. So some examples I will show, which is live here. So this is one digital twin that was developed as a proof of concept for managing one huge property in Bahrain. It's a Four Seasons hotel. So let me just click here and then take you to that. Once again, the prerequisite for having such kind of digital twin for a city or for a building is the platform on which you build the digital twin itself. So this is one platform called Next Space, upon which this ESRI also has got a platform upon which you can build. So this is a 50-floor building. I think the level is 51 floors. Yeah, 51 floors plus some technical floors as well. So this is how you see each floor is modeled. And
We couldn't see the.
this has
Excuse
this
me, sir.
house is yeah.
So we couldn't see the building, sir. The link is not open.
Oh,
Still, the
okay.
PPT is visible.
Oh, okay. I have to share the. Is it visible now?
Yes, sir. Yes, sir. This was visible.
Okay. So some of you who are familiar with Bahrain, who have traveled to Bahrain, you must have seen this building in the Business Bay area. So this, you see, this is a 51 floors building, and it houses a hotel, Four Seasons Hotel, which is very popular, and other floors are for residences, office spaces, and so many. It's a multi use building. So every floor has got so much of sensor data, HVAC sensors like heating, energy consumption, room temperature. It keeps monitoring on a continuous basis. You can see this here at any given. It's not a live. No, what I'm showing here is not live. Uh, you can see the type of attributes that is coming here. Energy sensor. What is the ID of that? What is the consumption of energy? How many kilowatts? About this temperature sensor, everything, floor area, how many rooms, every single thing is here. And this gets dynamic once the temperature changes from 12 degree to 15 degree, 18 degree. It keeps reflecting here. So currently this is not live, that's why it is stagnant. For every floor, you can imagine the building management unit, which comprises of engineers, electricians. So many people are needed to build manage such kind of 50-floor building. So they can all sit in one single office, one single room, control room, to monitor the whole building instead of sending people all over the floor to different floors for maintenance people to take care of it. So they can keep monitoring if there is any malfunction in any of this particular floor, whether air conditioner have stopped working, automatically the temperature goes up, and then when the temperature goes up, there is an alert that is already sent to the central monitoring unit, so in order to take actions. And also this particular hotel, everything, the northern part of Bahrain is completely uh, reclaimed from the sea. So you can see that they have made a artificial island and built this one. So a small rise in the sea level would flood most of the area. So this also can be monitored. Like there are sea level, water level monitoring stations around. So that is continuously monitored due to some kind of no one knows. Like if there is any uh, tsunami or something that is originating from somewhere, nobody knows. But these kind of sensors will help monitoring all the water levels, and then quick action can be taken for uh, um, moving the people to safety, or necessary actions to be taken. All this digital twins can be very handy in many types of problems, whether it is related to disasters or related to maintenance of the buildings, and so on. Let me go back to the slide. Similar kind of this thing was for city as well. Are you able to see the screen?
Yes, sir.
Okay, so this is Dubai city, where this is a digital twin of the business Bay Area, where this is a Burj Khalifa. So, what is the advantage of having such kind of digital twin? Like you can model this, you can see this completely modeled, and you can add all this kind of flows, add connect all the sensor data to it, IoT sensors and other data to it. Keep monitoring it for the yeah, keep monitoring for uh, the purpose that you want to do it. But the common denominator for all those things is first to get the digital twin developed for this kind of cities or buildings, whatever it is. So this technology is very handy, and this is a proven technology for such kind of applications, whether it is for disaster management or whether it is for property management and so on. Okay, and now I'll move back to the presentation. Yeah, let us know if you are able to see the screen.
No, not it, sir.
Are you able to see the screen now?
No, sir.
So lag. Now, madam?
Yes, sir. Now it's visible.
Yeah. Okay. So like this, there are many similar kind of digital twins that are made in different cities. Some of the examples are given here from history. So you can click on this and then explore more about these 3D and BIM models. See, this is the subsurface asset registry that I was talking about. You can see this in 3D. These are all the piles, and below the ground, in Netherlands, if you see, all this building has got so much of underground piles. So each one is registered in the registry for subsurface data. If there is a tube that is a metro underground metro that is going below these piles, so all those things have to be recorded in Netherlands. But whereas in India we do not even have that kind of system where there is a separate registry for underground assets. And another type of disaster you might not have heard in Indian context is like vegetation management. See, this is a high tension power line that goes in US and other countries, and the vegetation is grown all along those lines. So this vegetation sometimes grows and then it reaches and touches the high tension lines. So there is a program that the local bodies and the other utility companies that they run to keep to prune the trees till so that it doesn't reach and touch the high tension lines and so on. So even for that, if it touches, there could be a disaster. Some accident could be there, some fire can take place and so on. So this is another technology using lidar technology, which clearly identifies which particular stretch of trees are taller than the other one and which needs pruning and which does not. So this is another use case. Then asset lifecycle management is one of the important thing that can be handy with the digital twin. Underground assets as well as above ground assets. With this, I've come to the end of this presentation, and I'd be more than happy to take any questions or someone want to discuss something before closing.
Participants, if you have any questions, you can ask now. Anybody?
Participants, you can post the questions in the chat box also if you're not able to unmute.
Thank you so much, organizers, and thank you so much for everyone who attended, took out your time to attend this session. I think this session has given some insights about the use of artificial intelligence and IoT and how the use cases are there in India as well as in other countries internationally, and what is the way forward, how the systems can be designed and everything. So if you have any questions, please post them to the organizers so that they can send it across to me. So I'd be more than happy to answer them. Over to you, Krishna Kumar. Thank you so much for coordinating, and Dr. Gauri.
Thank you so much, sir. This was a very insightful session, sir. We had a lot of information from your presentation. Thanks for this wonderful learnings you have given to us, sir.
Thank you so much.
Gauri, ma'am.
On behalf of SRM Madurai College of Engineering and Technology, like we thank Dr. Senthil sir for giving your valuable time. Like this presentation gave us a real different dimension where we could understand the real scenario which is taking place at the international level. Like we could see so much of technology that is being related to whatever we read as of now in a conceptual level. So this platform has given the participants to understand about the real application of the AI and IoT, which is still like a dream for a country like us, like where it is still in the development stage.
Yeah.
So maybe in the future, near future, we should be able to accomplish such things. Thank you, Professor. Thank you so much for your valuable time which we have spent along with us. Uh, Thanks a lot, really.
Thank you so much. Thank you so much, madam.
Thank you, sir.
Yeah. Thanks to SRM College as well. Yeah. Thank you.
Is there any people from computer science background right now? Participants, if you are from computer science background, please post it in the chat box. So now we are going to have our speaker from computer science background right now, Dr. G. Devasena. So she said to join. I think.
Good evening, ma'am.
Ma'am,
You're most welcome to this session, ma'am.
Yeah, good evening, ma'am. Good evening. Can you
ma'am,
hear
good
me?
evening.
Yeah,
Yes,
good evening. Good evening, sir.
shall we start now, ma'am? Or if you are ready, we can start now. Shall I start?
Yeah.
Yeah.
So we can start, sir. Please make sure that all participants joined.
Yes. Yes. So, once again, good evening to all the participants. Now we are in session number 10, and here we have Dr. G. Devasena, working as assistant professor in computer science department at Indian Institute of Information Technology, Tiruchirappalli. She has more than 8 years of experience, and she's also holding many sponsored projects. And she is familiar in patent grant, as well as more than 10 plus journals, recognized journals. And her area of interest is image processing, AI/ML, DL, and Gen AI. So, with this brief introduction, I would like to welcome Dr. G. Devasena for this session to speak about AI geospatial technologies for disaster management. Ma'am, you are most welcome, ma'am.
Yeah.
The session is over.
Yeah, thank you, sir. Thank you so much for giving me such a wonderful introduction about me. So, shall I share my screen? Is it visible?
Yes, ma'am, it's visible.
Yeah, shall we start?
You can keep it in the full screen mode also if you want. Yes, ma'am.
Is it?
Yes.
So, can you just check the slide movement?
Yes, ma'am.
Is
Yes.
it? Yeah. Okay, fine. Yeah, as sir introduced, good evening, everyone. So, thank you for patient listening. Actually, it's around 7:30. So, I think you are all from back to home and you are attending the session enthusiastically. So, the topic given to me is AI plus geospatial technologies for disaster management. So, I would like to share my viewpoint about the geospatial technologies and how you can collect the data and process the data using AI technologies. So, which would be very much useful for managing the disaster or uncertain situation. So, these are the very crisp contents available in this presentation. So, first we need to understand why we require AI technologies for handling disaster management and how the traditional system was doing that and why we need AI and how we can define the geospatial ecosystem and moving to spatial data mining and after that AI techniques for disaster analytics. So it's a short introduction. I think this is fourth day. Am I right, sir? Is this a fourth day of this 1
Yeah.
week?
Yes, ma'am. Yes, ma'am. Fifth day actually.
Yeah, fifth day. Okay, fine. So you might have gained some knowledge about the geospatial management using IoT and AI from other experts. So with that introduction, so I want to skip directly to AI technologies much. I didn't cover much part in the introduction about the disaster management and all. So since I'm not a civil person, so I cannot dive deeply into this disaster management and all the technologies. Well, perhaps I can move to AI technology so that you can understand how AI is useful for managing the disaster situation. So in general, as far as AI is concerned, everything is data. Whatever we want is data, right? So with respect to disaster management, spatial data is more important. So in general, when we are writing programs and all, we will be using some data types like integer, float. I think everyone has some basic knowledge about C programming. So the basic data types are used to store some real world objects like marks or any entries, right, with different data types like integer, float, character, such things, right? But those data types are not sufficient for defining the spatial data. So in addition to those data types, we need some other location specific data need to be stored in the database. Then only we can process the data, right? So that would be very helpful. So there are three aspects in that. So one is how to collect the spatial data, how to store the spatial data, then next comes how to process the spatial data, right? So in basic programming, when we are storing a variable like int a equal to 10 or int b equal to 10, so first we are telling the computer that this is a variable which is of type integer, right? So some amount of memory space will be occupied for this information, and the data will be stored on that memory space. And whenever we want, we can refer that memory space and we can process the data. In the same way, first we should collect the data from the outside world. So for that, sophisticated sensors and satellite images and so many other UAV drone based information, right? All those are available, right? So first we need to collect the spatial data, and after that we got to store it very carefully and organize the data in a proper manner, so that whenever we want, we can take the data from the database. After collecting the data, then we have to proceed with the mining process, applying some AI models for some prediction or some monitoring purpose. So after predicting something, we have to do something in addition to that, like alerting the people, right? Once something is going to happen, then immediately we have to inform the people to move out, right? So it's not going to stop with prediction. So after analyzing what needs to be done, right, for the society, so those will be handled. So how to handle the risk assessment, right, and damage mapping. So these are all small tasks, right, that is very helpful for the society to move to a better place. So the first topic is need for smarter disaster management, right? So traditional plans mostly rely on static maps, right? So the dynamic updation won't be there. So whenever the spatial data is considered, it will be collected with respect to time zone also, right? So for example, if there is a cyclone flood announcement, so what will happen? They will keep on tracking the movement of the clouds, right? Hourly basis, in which direction it is moving, right? How it is strengthened hour by hour. So such spatial as well as temporal information need to be collected, right? Spatial data will concern about the geographical location of the particular incident, and the temporal data will give you how frequently it is getting strengthened, right? Hour by hour, right? So both are important. But earlier we will collect only the static maps that may be collected 2 days or 1 week or 1 month, 1 month ago, and with that we cannot do any kind of immediate action, right, during the cyclone or the flood, right? So that's why, since the data is more dynamic, we need to collect the data quite often, and we have to quickly act on what needs to be done for the society. So that is a major aspect of disaster management. In case if any uncertainty happens, right, for example landslide or tsunami, right, anything, right? So the next step is how to recover the people from that situation, right? How can we not only the human beings, in addition to that the vegetations like plants and the animals, right? So all are part of this earth. So we need to have more concern about all these things, and we need to recreate everything once again, right? So for that, right, early risk detection and planning can be done with the help of AI and geospatial data together, right? So some models you can develop, and based on the historical data, you can predict the upcoming disasters, and accordingly you can plan how to handle that, so that you can, like the government can provide the red alert, orange alert, everything. So this analysis will be very much helpful, provided if there is bulk amount of data available in the history, right? If the data is not available that much, then it would be very difficult to do the analysis. And real-time situational awareness, right? So continuous data streams need to be collected from the satellite or through any mechanisms, right? Airborne sensors are there, through drones you can collect. So real time means continuous supply of data will be coming, right? So those data can be applied on the AI systems to identify the emergency arises in that particular location, right? Because of the so and so data collected, right? And optimize the emergency logistics means, so whenever some emergency happens, right, immediately the transport or food need to be provided to the people, affected people. So how can we do that in a better way, in a quick manner? So that is emergency logistic handling. And recovery, after disaster happens, once again the road need to be constructed, house need to be constructed. So all these are after the disasters, right? So in each of these steps, the entire flow of disaster management, right, AI plays a major role. Not only AI, without geospatial data, it's not possible for AI to work on with the disaster management. So what are the traditional limitations of traditional disaster management system? So earlier rule-based models are built, right, that lack adaptability. Rule-based models means, so based on some condition, for example, if the temperature is very low, then there is a possibility of raining, right? There is a possibility that we will be getting raining. So if rain comes, then we need umbrella. So this kind of if then rules are called rule-based model. So from the data, this kind of rules will be developed by the model to find the predictions. So such kind of rule-based models lack adaptability, right? Adaptability means, so now and then there may be possibility of some data may occur that violates the rules. In case of that rules, it will give a wrong prediction. So the changes happen in the data need to be captured by the model. So traditional models cannot do that. So manual interpretation of satellite imagery. So when you are looking at the image, to some extent we can understand what are all the objects available on that, right? But every time we cannot extract some features and fed it to the AI models. Manual interpretation is very, very difficult. For example, if you are having 256 by 256 image, so there will be 65,536 pixels are available in that image, right? So we cannot consider each and every pixel, right? It will increase the complexity. So we have to extract some features from that bulk amount of data. So manual collection of or extraction of such features are very, very difficult from the images. And delayed situational awareness, right? So for this disaster management applications, right, the quickness, alertness is required always, right? So that we can handle the disaster to some extent, right? And limited integration across agencies and the data silos means, so there are so many satellites available. The data need to be shared among all the satellites and it should be given to all the countries, right? So that should be shared. So there are some limited integration. Integration means combining data from multiple sources, right? So these are all the challenges in the traditional disaster management. But with the evolvement of AI technologies, so this can be handled, right, overcome with the recent updation happened in the artificial intelligence that is automated. Instead of manual interpretation, automated feature extraction can be done from the images. So this will reduce the complexity of the human to extract the features from the images. And Since the algorithms are very sophisticated, it would be very easy to learn complex nonlinear disaster patterns, right? So nonlinear means, so basically linear means if X increases, Y also increases. Nonlinear means you cannot go with that flow, right? There may be uncertainty. It's not necessary that Y should always increase if X increases. So that is non-linear. So if there are more dependencies in the variables like x1, x2, x square, like so many variables are there to predict the value of Y, then it would be very complex. So the learning complex patterns is very much easier in AI. And it has some scalable real-time analytics, right? So we have sophisticated memories available and network capacities available. So we can deal with the real-time analytics in a faster manner. And apart from that, decision support under uncertainty, right? So we are analyzing the data, finding the patterns. Everything is for sake of making suitable decisions under uncertain conditions, right? We will be seeing like how it is possible with the help of AI technologies. So for sake of understanding what is the role of AI in disaster management, I have gone through some papers and review papers. So these are all the summarized idea in the publications, right? So here there are 3 columns available: the purpose of analysis. So in this purpose of analysis column, you can find different disaster problems given, right? So for example, flood, landslide, earthquake, right? And classification of building damages, right, during the earthquake, right? And the second column, the middle column, right, deals with what are all the AI algorithms, right, proposed by the researchers to deal with this disaster issues, and what are all the input data given to the algorithms, right? So this survey gives me the idea on how to prepare the slides for this session, right? So according to this flow, I have prepared the session. Okay, so what are all the inputs they have given? Satellite images, remote sensing data, then 3D point cloud and UAV images. So if you look at the AI algorithms, ANN, we call this as artificial neural network, then random forest, naive Bayesian classifiers, then support vector machine. So these are all the algorithm names, right? Convolution neural network. So all these are convolution neural network. So I plan to give some introduction about how ANN and CNN works, even though a lot of algorithms are there. So this will be very much useful when you are dealing with the images. So all these are given in the upcoming slides. So this is a continuation of the survey that I have done for some more papers. So fire detection, like early fire detection, burnt area mapping, then earthquake, everything. So if you consider the input data, all satellite images, UAV images. So most of the data are of type image, right? So this is an important point. And so if you look at the algorithms, AI algorithms, again, they have a lot of neural networks, right? So different variety of neural network algorithms. So based on this idea, I got split it into 2 parts. One is dealing with geospatial technologies, another part is AI and ML. So when you are discussing with geospatial technologies, so these are the techniques that helps us to collect the geospatial data, right? So these are all the hardwares or techniques available to collect the geospatial data, right? So through geographical information system, remote sensing, GPS positioning system, photogrammetry, earth observation, right? Through drones, UAV, LIDAR, so many things are available to collect the data, right? And after collecting the data, we got to perform some analysis on the data, right? So before developing a AI model, first we need to understand the data, right? So for understanding the data, we have to apply some mining technologies, data mining technologies, right? So through mining techniques, we can understand the data in a better way, how it is distributed, what are all the hidden patterns or useful patterns inside the data, and if there are any noise information available in the data, how to deal with this, because whenever the satellites are capturing the earth, right, so there may be some disturbances in between, right? Clouds may cover some of the land area, right? So how are we going to deal with these noise information, and how to understand the nature of the data? So once these parts are very clear, then we can easily develop the AI models, right? So in AI models, what are we going to do? So regression, obviously regression will be used for predicting something, and classification, after finding something, some patterns, we can classify. This is apple, this is building, this is road, right? So some kind of known labels will be assigned for particular spatial data. Then clustering means grouping the data, right? Spatial data. So apart from that, you can use deep learning, right? Moving from machine learning, we can perform some deep learning on the data, right? Which helps us to extract the features automatically, right? So without human intervention, the deep learning models will extract the features from the images, right? And it can be used to transform into some other space, right? So in addition to that, spatio-temporal models are also available, right? So spatio-temporal models means considering into spatial as well as the temporal resolution of the data, how the model is learning. So there will be some continuous like connectivity between one data to the previous data with respect to time zone. And apart from that, NLP can be used for preparing reports and convey the same to the social media. Interpretation of the information obtained from the model and convert it into text format to the outside world, right? And this reinforcement learning technologies are used for handling the resources in a optimized way. So coming to the geospatial ecosystem, right? As we all know, right? Life is very uncertain, right? The entire earth is uncertain. So geospatial ecosystem is a dynamic, right? Anytime, any changes may happen, right? So it's an interconnected network of technologies, data, and stakeholders, right? So who are all the stakeholders in the disaster management? Government, industry, academia, right? So as we are academic people, we are doing some research on how to handle it effectively. So through our proposals, government can make use of those proposals to implement it, right, for the people, right? So that collects, manages, analyzes location based information to support decision making. The ultimate aim of using these technologies is to make some good decision, right? So for sake of that, all these analyses are done. So it merges technologies like GNSS, navigation system. So it is geographical information system, remote sensing, LIDAR, right? SAR, synthetic aperture radar, right? So these technologies are used for collecting the data about the disaster happened in the earth, right? So through earth observation satellites, UAVs, everything. So each kind of sensors and the techniques are having its own properties or own way of narrating the data. For example, LIDAR applies light radiations right? So you can use sound radiations, right? So in different way, the data can be collected. So basically, the images are coming from the satellite, right? So apart from that, you can also make use of drones or some UAVs to collect the data. So satellite images help comprehend and manage natural disasters, right? So high resolution satellite imageries are available, right? Often released by IMD, right? Which we people like academia can make use of those images to do some research on how to do this disaster management effectively, right? So the main advantage of satellite images, its capability to provide unparalleled coverage, especially in remote or inaccessible regions. Because when there is a war, right? If there is a war, right? So it is very difficult to send a human being to some danger zones, right? Inaccessible regions. So instead, we can send the drones to collect the data about the enemies, right? So even in case of hurricanes or any flood, right, deep into the sea, we can send something instead of sending the human being, right? So for this, we can make use of the satellite images. And integrating satellite image with advanced technologies like advanced deep artificial intelligence can further enhance the disaster related analytics, right? So these are all some introduction about how we can collect the geospatial data, like airborne sensors are available. So you can send those sensors through UAV or manned aircraft or unmanned platforms. You can make use of this airborne sensors to collect the information. Then LIDAR you can use, and camera, sophisticated high resolution cameras can be used to collect the data, right? So multispectral, hyperspectral sensors, right, capture data across multiple bands, enabling detailed analysis of vegetation health. So even you can predict the health status of the plant, right? Whether it is infected or whether it is growing properly. So everything can be monitored, right, with this help of these hyperspectral images. And thermal imaging sensors are available, right, to detect heat signatures, right? If there is a fire, right, forest fire, you can make use of thermal imaging sensors, and you can combine that with the drones and you can collect the information. So similarly, through light, you can use LIDAR sensors, right, to collect the information from some spatial information from the locations. So it uses laser pulses to detect the objects. So in each and every technologies, it applies different mechanisms to collect the data. So similarly, SAR employs microwave pulses, right? And so the nature of the data will be different in different types of inputs. These are all the input devices, right? So through which the data has been collected. So the nature of the data will be in different format and possess different characteristics. So before doing analysis, we need to understand in which format the data is available. Okay. So in general, we will be using this remote sensing studies electromagnetic radiation from the Earth's surface, and accordingly, it will be reflected in the satellite images, right? So altogether, what I'm trying to convey is through many input devices, we can collect the data, and the collected data will be in different format and different characteristics are there. So you have to make use of these information to build a spatial database, right? So before constructing the spatial database, right, you have to mind about the spatial resolution and the temporal resolution. So spatial resolution determines the ability to discern fine details and distinguish between objects or features in an image, because whenever the images are available as per the human visual system, you cannot find much difference in the nearby image regions, right? The changes happening in the images will be very, very drastically, the changes will happen, right? It won't be evidently visible to the human visual system, but the machine can capture those changes. For example, if there is a color, right? So if you take the grayscale image, the ranges will be 0 to 255, right? 0 represents black and 255 represents white. In between 255, different colors are available, right? So different shades, like 1 is a different color, 2 is a different color, 3 is a different color, but the human visual system cannot identify the difference till up to 30, right? But system can identify the variations happening in 1 and 2, right? So that's why it is very important, right? Spatial resolution means it has its impact on the nearby regions also, right? So you're going to look at one object, but it has some impact on the nearby objects as well, right? So that kind of spatial analysis need to be done on the object that are available in the particular image captured by the satellite. So it refers to the level of detail captured in the image. So level of detail in the sense resolution, right? So 4K camera, right? So what is the meaning of the resolution? We have now sophisticated televisions, right? UHD, ultra high definition, means lot of pixels will be used, right? The resolution will be very more to get the clarity of the picture. So you can collect the different level of details, and accordingly you can do some analysis on how small or closely spaced objects or features can be resolved, right? So spatial resolution is typically measured meters per pixel, right? Meters per pixel, indicating the size of the ground area represented by each pixel in the image. It is a kind of scale that we apply on graph, right? When we are creating a graph, we will be applying some scales. So similarly, you can apply the resolution size, right, as per the required application, right? So factors influencing spatial resolution include characteristics of imaging sensor, altitude and platform from which the sensor operates, and the processing techniques. So these are all the part of spatial resolution, right? So these parameters determine the data, right? And high spatial resolution results in smaller pixel sizes and finer detail, but it often comes with trade-offs such as increased data volume. We need to provide large amount of data to store such images, accurate images, high resolution images. And regarding temporal resolution, so time need to be considered, right? Time zone need to be considered. So it refers to the measurement value assigned to the observations or measurements throughout a given period, right? Hour by hour, minute by minute, second by second, right? How it is getting the severity, right, needs to be analyzed. The speed of the movement of the clouds, right? Wind, right? How the temperature is changing all of a sudden. So with respect to time zone, we need to analyze the data. So which serves as an indicator of the speed at which the data is gathered or revised. So it impacts the system's capacity to observe and analyze changes, patterns, and occurrences, right? So temporal resolution in satellite-based Earth observation system is commonly measured using revisit time, right? So when you are tracking the weather.com, right? So you can go back, and there will be a time slider, right? So you can go back and move forward also, right? So based on the prediction in the upcoming hours, how the position of the clouds will be can also be predicted by the software, right? So the high temporal resolution system enables the regular observation of the dynamic process, seasonal variations, and short-term occurrences with a high level of temporal accuracy. So as far as geospatial data is concerned, both spatial and temporal resolution need to be considered, right? So you can consider this disaster management as a spatial temporal problem, because disaster evolve across space and time. So multiple data sources with varying resolution and uncertainty is available, right? So you have to collect the data from multiple sources, not only with one particular satellite image. You have to collect the data with different sources, and those data will be used for doing predictive, prescriptive, and analysis, and adaptive system is required, right, to do such analysis. And geospatial context is central to decision making, right? So the ultimate aim of doing AI technology is to decide, right, efficiently as per the according to the situation. So once the data is collected from all these sources, now it's time to do some mining process, understand the data in a better way. Then only you can proceed with developing AI models. So how you can approach the spatial data, right? So coming to this spatial images, right, collected from the satellite, it will have some spatial objects as well as non-spatial objects also. So let me give you what is spatial objects. So these are all objects that occupy space, right? It has some geographical locations. Whenever we are considering about the space, always satellite images will come into picture. But say here in medical images also, the location of the tumor cells matters a lot, right? So it will be identified with coordinates, right? In which part the tumor cells are available, right? So it has very important meaning, right, when the spatial information is added to the objects. And spatial objects usually consist of both spatial and non-spatial data. So you can ask me, what are all the non-spatial data? So here are the examples. So spatial data is nothing but the data related to spatial description of the objects. That is coordinates, area covered, latitude, longitude information, and what is the perimeter, and the spatial relations, right? How the other object is related to this current object, right? So whether it is in the north direction or nearby, so such kind of relations can be defined, right, based on the distance, topology, and direction, right? So they have given example, earthquake points, town coordinates on map, right? So these are some of the examples for spatial data. Then what comes non-spatial data? It is nothing but the data that is associated to the spatial objects, right? So this is point, earthquake point means exact location is required, right, where it is more. Earthquake degrees in the sense to which degree it is spreading, right? So this is additional information, right? Town coordinates means with respect to latitude, longitude, you have to define on map. But population of a town is a non-spatial data information, right? So spatial objects can be classified into different object classes and several classes can be hierarchically organized in layers, right? For example, so this is the general hierarchy. We call this as concept hierarchy. Countries, then state, then district, then streets, right? Village, streets, like that it will go, right? It is called concept hierarchy. Okay, how to build a spatial database, right? After collecting the data from multiple sources, we need to store it effectively, right, for further analysis. So we have in CSE database management system. I think you might have heard about this word, DBMS software, right? Which helps to store the data in a tabular format in general, right? So apart from that, if multi-dimensional data are used, then we can construct a data cube, right? So the data cube will be constructed and stored as a bulk data warehouse, right? So it's a repository, data repository. So many spatial database architectures proposed for managing both non-spatial and spatial components of spatial objects, right? So you can use regular DBMS software for storing non-spatial data, but for storing spatial data, in addition to the normal data, you need to store the coordinates, right? Some of the geometrical information like lines, right? Circle or polygon, the area covered, right? So all these information need to be stored in the database. And in addition to the relational properties, how one object is close to other object, right? So through this only you can identify what are all the villages available in the seashore, right? So in case of any emergency, the first alert will be given to the people who are living in the coastal area, right? So accordingly the range will be different for the inside regions, right? So relational properties are also more important. So in general, the spatial database store a large amount of space related data such as maps and pre-processed remote sensing images, and you can even store a VLSI chip layout data also, right? So you can carry out topological distance information, calculate all these information. So usually organized by sophisticated multi-dimensional spatial indexing structures. So in general, we will be storing multi-dimensional data, right, in different aspects, not only with only two aspects. Two aspects means with respect to only latitude X or Y, then it is restricted to two dimensions, right? Apart from that, you can add more dimensions for the data. And when the database is bulk, right, so you need to indexes, means, so in the textbooks you can understand what is the purpose of index. At last index will be available, right? So this index will help us to search a word, right? So the index will be created as per the alphabetical order, each word along with the corresponding page numbers, right? So through the arrangement of words, we can easily identify the occurrence of the words in the book, right? Similarly, to identify a particular record, right, you can apply some of the indexing structures to effectively conduct the search on the spatial database. So we call this as spatial data structures, right? So spatial data structures will be like this. So you can define anything like using some geometrical structures, points, lines, right? Square, bounding regions with different shapes, right? So in this way, you can deal with spatial data structure. So apart from that, you can use multi-dimensional trees for building the index, right, on the spatial data. So for that, so these are all regular data structure mechanism, but those traditional data structures are extended or expanded for dealing with the spatial data using R trees. In general, we will be using binary tree, but here R represents region. Region tree will be created. See here, this is the region tree, level 1, level 2 data, right? So if you look at this, within one square box, it is partitioned into multiple regions, right? So each partition has different structures in level 2, right? Different regions in level 2. So this you can consider as entire country, then partitioned into multiple states, then final partition into districts. So in this way, you can construct different level of information as a tree structure. So this kind of tree is called R tree. Then you can have another version called R star tree. So these are all the traditional mechanisms to organize the spatial data. So this is one simple example. Using software, you can deal with the spatial data in GIS. So this is the particular spatial related data, right? Some object is available with respect to some coordinates. So these are all the traditional relational databases for storing non-spatial data, right? So you can just look into this. Some informations are available in the table structure, right? And here the coordinates, right? East, north, coordinate, latitude, longitude information is available for the particular object, right? So it contains both spatial as well as non-spatial data. So these are all some of the relations, right? When you are doing some processing on the spatial data. So for example, if you are having integer data, right, then you can perform arithmetic addition, subtraction, everything, logical operations, and all those things. So similarly, for if the data is of string data type, then you can perform reverse the string, finding a character in one particular location, like particular index, what is the fourth character, and how to extract some substring. So these are all the operations related to string data type. Similarly, for spatial data type, you can perform these operations, right? Topological relations, right, can be given, like intersect, overlap, disjoint, whether two objects are intersecting with each other or overlapping, or whether they are independent in nature, like disjoint. And with respect to distance, close to, right, far away, how to define these words, right, computationally, right, with respect to distance and with respect to direction, right? So these relations can be provided to the objects available in the image, right? So for each relations, they have given the example. Disjoint means both are completely different. Overlapping, some part is overlapped with the other region. So this is containment, right? A contains B. So likewise, you can define the relationship between two objects with respect to direction also, right? Northeast, southeast, like that. Okay. And this is how the databases, right, spatial database look like. So it contains partial spatial data and partial non-spatial data. So here, in addition to the regular parameters, you can have like this, whether the given house is close to railway, right? Close to railways, it will find how far it is, right? What is the distance between the house and the railway station? So accordingly, the answer will be stored in this place. So inside city, whether this house is inside the city or not, right? So these are all some of the additional computational information about the spatial data. So after constructing the data warehouse, what are we going to do with that data, right? You can perform spatial data mining, right? Data mining in the sense digging deep into the data, and we are trying to find some useful patterns, right? So if tsunami occurs, what are all the previous sequence of events that are happening on the sea, right? So that is pattern, right? So if we understand that pattern, then immediately we can alert the people if such pattern occurs, right, in the future, right? That is the purpose of doing this, identifying the interesting patterns. So extraction of knowledge, right? If you simply look at these numbers, you won't get any idea, right? So that's why data mining technologies have been developed to understand the data more. Excuse me. So, data mining techniques are used for understanding spatial data, discovering spatial relationship and relationship between spatial and non-spatial data, constructing spatial knowledge bases, reorganizing the spatial databases, and optimizing spatial queries, right? If any user, right, applies some queries, then the system should able to get answer from the database, right? So using this, there are so many applications available, right? The crucial challenge is exploration of efficient spatial data mining techniques. It's a challenge due to the huge amount of spatial data and the complexity of spatial data types, because it not only contains the data object but also contains the related information around that particular object, right? And some spatial access methods also need to be developed along with storing the spatial data. So the main difference is that neighbors of the social object may have an influence on the nearby object. That is the problem. So when you are dealing with integer, character, string and all are considered as an independent variable. But here with respect to spatial data, you need to take care of the nearby objects as well, because it has its impact on the nearby object as well, right? Because it is often interrelated. So more exactly, spatially co-located. We call this term as co-located, right? So co-located means what is the relationship between one object and other object with respect to directions or distance or any topology, right? In the sense, the closer the two objects are located, the more likely they share similar properties, right? As I told you in the image processing, like we cannot identify the difference between 0 to 15 pixel values with a human visual system. Only the machine can identify such differences, because all by nearby pixels are interrelated with each other. There won't be much drastic change. The change will be happening very drastically, right? Not drastically, sorry, very smoothly, right? So very smooth variations will be there in the pixel values, right? So that's why they are more interrelated. Okay, so how to deal with such data, right, is defined by spatial data mining algorithms, right? Explicit location data and implicit relations of spatial neighborhood. So this is one use case, right, created by the professor, right? So during the occurrence of the past occurrence of the event happened on the London, right? So they identified that a disease is spreading in one particular area, right? So they want to analyze the cause of the disease, right? So this is a disease cluster identified by the satellite image, or after performing some data mining algorithm, they found that these are all the infected zone, right? Infected region, right? So they try to identify, or they try to find the reason for the cause of the disease, right? So this gives the idea of tracking the infected water pump, right? Underlying water pump, right? So they try to identify where the pump is going, how many areas are, like how much area are covered through this pipeline, right? Because the people are getting the disease because of this infected water, right? So this is a simple use case they have used, right, by applying data mining algorithms. So representing the spatial relation of the object is more important when you are doing the analysis, right? Representation means, so simply we cannot draw a circle on the collected data, am I right? So this is a manual interpretation, right? But we make the machine to draw such circles on the map, on the spatial input data, right? How are we going to represent the relations, right? How are we going to find the bounding regions, right, with the help of circle or rectangle or any shapes, right? The area coverage need to be identified by the machine, right? So we have other spatial patterns in the examples. For example, cancer clusters and crime hotspots, Nile virus spreading, right? So there are several issues, right? Goal of the main goal of the spatial data mining is to identify the spatial patterns, right? So identifying spatial objects that are potential generators of the patterns. Not only patterns, the data objects associated with that pattern, and identifying information relevant for explaining the spatial pattern, right? So if the explanation is not found, then we cannot rely on such spatial patterns, right? So we need to collect the underlying truth about the spatial pattern as well, right? And last but not least, after finding the pattern, we need to present it in a graphical way, right, to the higher authorities for further decision making process, right? So presenting the information in a way that is intuitive and support further analysis, right? So for that, several visualization techniques are available in the data mining. So in general, these are all the spatial data mining tasks, right? So we have association, right from developing the warehouse, right? So classification can be done, clustering, association, and prediction through regression analysis, and time related sequential pattern can be found out, right? So I have given the a few slides on the glimpse of these data mining tasks. So the first one is spatial data cube construction. So data cube means multi-dimensional data, right? So it would be like this. So 3 dimensions. Yeah. Through this example, I will tell this. So if you look at this is one architecture. We call this a schema type, right? Star schema, right? Different schemas are available in building a data warehouse. So the schema will be developed using 2 tables. One is fact table, another one is dimension table. Dimension means different aspects, right? So this is region dimension, this is time dimension, and this is temperature dimension and precipitation dimension, right? So each dimension carries different information, right? So all these essential information are stored in one fact table, right? So this is a kind of centralized table, right, which has detailed data on individual dimensional table. So this is a kind of star schema type, right? So the entire map information will be stored like this in the data warehouse. Okay. So here there are 3 possible choices to compute the spatial data, right? One is collect and store corresponding spatial data pointers, but do not perform any pre-computation of spatial measures on the spatial data cube. Means straight away you can collect the data from the satellite and you can store, right? And another one is pre-compute and store a rough approximation of the spatial measures in the spatial data cube, right? Some kind of pre-processing, like removing the noise, right? So such kind of pre-processing techniques can be applied on the collected data, and after that you can store it on the spatial data cube. And third option is selectively pre-compute, right? Not all the data, right? Selectively pre-process some data and build the spatial data cube, right? So I'll just move to some of the techniques. Yeah, location prediction, right? So for location prediction, we can use classification or some regression function determination you can perform, and interaction correlation. So what is the association between the 2 spatial objects can be found out, and using hotspot techniques you can identify the outlier. So outlier means it won't come with the rest of the data, right? So it will stand alone, right? It will stand alone. So for example, for criminal analysis, right, the outlier plays a major role. Fraudulent detection, right? Fraudulent call detection, spam detection. So these are all outliers. It won't have the common properties similar to other data, right? So this is also helpful to identify the hotspots, right? Infected regions, right? So outlier detection is a major technique, data mining technique in the disaster management, right? So how to identify the association? So very simple spatial association rule will be of the form S and C. S is the support count and C is the confidence rule, right? So support means how many data supports the relation between A and B, right, in some specified manner, right? For example, A and B are set of spatial or non-spatial predicates. S percentage is the support of a rule, right? So you can derive one rule and you can find out how many data supports this particular rule, right? From the database, you can find this. And confidence of the rule is to strengthen whether the obtained rule, the obtained rule is applicable for all the data, right? That gives the confidence value, right? So they have given a simple example. So is a relationship, right? If it is spelled like this, if X is a school intersection, right? And if X is close to sports center and both, right? So intersection means and condition, right? The first condition should also be true. The second condition should also be true. If both are true, then obviously the X is close to park, right? So this is the meaning of this. So for this rule, 0.5%, right, support is given, 80% confidence is given, right? So this rule states that 80% of schools that are close to sports center are also close to parks. That is a confidence rule. And 0.5% of the data belongs to such a case, right? So this kind of rule will be generated and complete analysis will be done on each rule, right? So that's why it is called spatial association rule mining, right? So based on the distance topological and spatial relations, you can perform this, right? So there are some methods available. I'll just go to one fine example. Yeah, this one. So it is marked, right? X and Y graph is given and there are some small icons, right, depicting the birds, house, trees, fire, all those things, right? So each object is marked, right, with some pictures, right? So you can find how many objects are associated with each object and how frequently they are occurring together, right? So they found that wherever the tree comes nearby, fire is there, right? See, for example, how many such data is there? One. So here it is, the fire is with bird. So you should not consider that. So here the tree is with fire 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So compared to other combinations, this combination is more in this distribution of the data, right? And similarly, bird and house together, right? So wherever house is there, the bird is also there, right? So this is the association between the spatial objects, right? So this kind of analysis will be done on the spatial data and the patterns are identified, co-location are identified. So to strengthen this, some co-location rules can be generated and accordingly you can find the related spatial objects, right? So other data mining includes clustering, right? So clustering or identifying the densely populated regions according to some distance measurement. And similarly, spatial classification analyzes spatial objects to derive classification schemes, and trend analysis can be done. Trend analysis, what is the changes happening in the earth or with respect to some spatial information, right? Trend analysis and many more data mining tasks can be done to deal with the traffic flows on highways and city planning, everything. So I have given some of the clustering idea. So I'll just look into some clusters. Yeah. So this is how you can do the clustering, grouping of the data, right? So with here in this example, in the map, they identify some clusters, right? Clusters means some group of data objects which possess similar properties, similar characteristics. So spatial clustering in the sense with respect to spatial data, right? So grouping can be done. So using this, you can identify the hotspots, right? Hotspot means it won't come along with the other data, right? It will stand alone. Some unique properties will be there, right? No common properties will be there. So by doing cluster analysis, you can easily identify the hotspots, right? So this is outlier detection, right? So something is available. So, okay, fine. So here spatial trend detection can be identified. There is a change. Whenever there is a change in the spatial data, you can easily identify the reason for this and what will be the consequences of such changes, right, happening on the clouds or on the waves or on the temperature, right? So you can do the trend detection, trend analysis on the spatial data as well. Okay, fine. So in order to perform some operations on the spatial data, you require the sophisticated computational hardware, right? CPU, GPU, TPU need to be used, right? Memory space need to be, much amount of memory space are required to deal with the spatial operations, right? So these are all some of the operations like intersect operation, inside operation. So this will look whether any object is inside another object or not, like that, right? So these are all some of the operations that you can perform on the spatial data. So this R tree, R star tree helps you to index, right? So this entire regions are stored like this, right? With TSR, 3 regions in the first level, right? So this is T, this is R, and this is S. So within T, there are 2 regions available, that is A2 and A6. And within S, there are 2 more regions available, A3 and A4. So like that, the entire map or image can be split into different regions, and the regions can be stored effectively with the help of tree structure, right? Called region tree, with the help of bounding box, right? So this square is called bounding box, which covers some regions. So similarly, you can have minimum bounding ellipse, minimum bounding circle, and minimum 5 corner polygon. So this is minimum bounding box, convex skull, right? So using any geometric shape, you can cover the region. Coming to the AI technology, so far we deal with spatial data mining, right? So first part covers how to collect the spatial data, and the second part covers how to mine the spatial data. The third part comes the AI technologies, because in the literature survey, most of the research papers utilize these neural networks, right, to find a solution for managing the disaster, right? So it is basically coming from artificial neural network by inspiring biological human brain, right? So how human brain is functioning. So let me quickly go to the crisp idea of how one neuron works, right? So this is a computation model given down. So this is the structure of the brain. So in which the nucleus is available, that is the central part of the neuron. So these are all some of the inputs given from the sensory organs. So the neuron collects the inputs from the sensory organs and it will process the input and it will convey some information to the next neuron through this axon. So this is the idea behind how our human brain works. So if you build a computation model, central part is node. So node is equivalent to nucleus here, right? So the input is collected from the dendrites, right? So these are all the input signals given to the nucleus and the nucleus process it. So similarly here, node will process the input and it will send the output to next node, right? So this is how it will be, right? So these are all the inputs, A1, A2, A3, like that. And each has its weight associated with that. For example, what is the meaning of weight here? See, if you observe, if a small mosquito is biting you, what is the pain level, right? If the dog, if a dog is biting you, what is the pain level? Both are different, right? So that impact is sensed by this weight, right? If the input is having much impact on some actions, then weight will be more. Otherwise, weight will be very less, right? So each input is associated with weight and the summation will collect all the combinations of corresponding input and the weight. For example, like this summation is calculated with A1 into W1 plus A2 into W2 plus A3 into W3, right? And after finding the aggregated value, the activation function. So this is a non-linear function because the complex data will come under non-linearity, right? So you cannot predict the changes happening in the data. So that's why we try to apply non-linear function to convert the given value into a non-linear value, right? So using some activation function. After that, the net value, AI, will be given to the next node, right? So let me show you like this. So this is the description of one neuron. See here in practical digit recognition system, you can assume the neural network architecture like this, right? So for one digit, right? So these many neurons will be in the first layer, input layer, hidden layer, output layer will be there. So in the structure, it is of simple neural network architecture with one neuron, right? So like this, you can think of multiple neurons in each layer. So this is the input layer. So each node will take one pixel value and 784 neurons will be available in the input layer, and you can define how many neurons you want in the hidden layer. Accordingly, you can design, and you can have more number of hidden layers also, and the output layer determines what is the corresponding digit for the given input image, right? So obviously, since it is a digit recognition system, it should be 0 to 9, right? So for particular neuron, the output will be, the probability value will be more, right? For rest of the neurons, the probability value will be less, right? So in this way, the artificial neural network is built to find the digit. Now you can apply the same for spatial images, right? So with simple understanding. So here there is no learning happens, right? So input is given, it is processing something and it is producing some output. But as far as machine learning and deep learning is concerned, the learning should happen, right, by the machine, right? No human intervention will be there, right? So the machine learning algorithms have to analyze the input data and the relationship between the input and the output data. Accordingly, the model should be developed, right? So here, this is a short description of how the learning happens, right? So here there are 3 layers in the neural network architecture, right? Input layer, hidden layer, and the output layer. There are some calculations available, right? So AA is not magic, it is mathematics only. right? So with some reasons, with some mathematical rules, it is conveying something, right? So let us try to understand how the machine is learning. There are three different layers: input, hidden, and output layers. So input layer, some input is given, right? And you know how the node, each node is processing the given input, right? Some summation will be there, and after that activation function will be applied, and it produces some intermediate output, and that output will be passed to the next layer, right? So from input layer, the value is passed to the output layer with some weights for each edges, and accordingly the computation happened within the neuron, right? And ultimately it produces some output in the output layer, right? So far no learning happens, right? So for the given input, it produces some output, that's all. But here is where the learning starts, through backpropagation algorithm, right? After producing the output, the algorithm tries to find the deviation of the calculated output with the actual output, right? We call it as target output and the predicted output, right? So that is T naught and Y naught. Y naught is the calculated output, T naught is the target output, right? So the difference between these two will be analyzed. That is error value. We call this as cost function, right? So the error difference will be identified. So we need to move to the target value, right? If the actual value is equal to the predicted value, then no problem. But if the predicted value is different from the actual value, then we need to look into that, right? So very simply saying, when we are conducting the test for the students, right, if the student is not scoring the mark up to the value, right, we will be conducting some compensation classes to adjust the mark, right, by giving some assignments, or by giving some small paper tests or quizzes, right, just to boost up the mark to some reasonable range, right? So similarly, the algorithm tries to adjust the weights, right? Input we cannot change, right? Input is a historical data, right? That we cannot change, but we can adjust the weights so that the end output will be moving towards the target output. It won't happen in one simple iterations. It requires multiple iterations to reach the target value, right? So this will be done in the learning phase, right? Basically, there are two phases. One is learning phase, another one is testing phase. In the same way how we are conducting classes for the students and conducting some internal test and the end semester test, right? So internal test help them to rectify their errors, right? So that they should not give wrong answers in the final exam, right? But for final exam, we won't help them, right? So that is the testing phase. So internal exam is a kind of training phase, right? So it gives the opportunity, right, to change the weights to a very small amount. Small change will be made on the weight based on the amount of error value, right? So randomly we cannot change the weights, right? So there should be some mathematical justification, right? So through gradient descent method, right? So we use the gradient descent method in the backpropagation algorithm to reach the target value. So this is how it will be. Initially, we will be assigning some random values for the weights, right? But as the iteration goes slowly, right, the weight will be adjusted to reduce the error, right? So at one point of time, the algorithm reach the minimum error value, right? So the algorithm will stop when it reaches this minimum error point, right? Once this state is achieved, right, the machine stops learning, because further learning won't change the error value much, right? So it stops the algorithm, and those weights are, right, used for predict the unknown input in the test phase, right? So during the learning phase, both the input and the output will be given. So
Sweta
input is given and the target value is also given to the algorithm, because without target value the machine cannot learn, right? So after learning, in the test phase only the input will be given and the value will be predicted, right? So this is the technology used, right, to learn. Next, coming to the CNN part, right? So most of the paper they have used CNN because it deals with the images, right? It helps the machine to extract the features automatically, right? So it consists of convolution. So this is an input image convolution. So next, pooling layer, I will explain what are all these layers are doing, right, in the entire architecture. So this final, right, so they have given fully connected layer. So this is the architecture, like this it will be, right? Fully connected layer is like this. So before giving the input to this layer, because instead of giving 784 pixel values, we can extract some features alone. For example, so the edge strokes, right? So edge strokes is the shape of the object, right? It can be fetched from the image and that can be given as an input to the fully connected layer, because this reduces the computational complexity. Okay, so the reduction of the data, feature extraction will be done, right, through this convolution layers and pooling layers. And after extracting the features, the fully connected layer will be developed, and this is the output layer, right? So this is a short description of CNN. Let us look into how one convolution process is done, right? So this is a sample image of size 8 by 8, right? So we call this as a filter, right? Intermediate small 3 by 3 window is there, right? So this is called filter. So we will apply filter on the images to extract some features. For example, this is a Sobel filter, right? So using Sobel filter, you can extract the edges. Edges are nothing but wherever there is a drastic change occurs in the image, it will capture. For example, look at this image, right? Car image is there, right? So how you can identify this as a car? Based on the shape, right? Based on the shape and based on the color, right? There is a difference in the color. Background is white, the car color is given as blue, right? So these are all the features: color feature, shape feature. Similarly, edge is nothing but the difference in the white and the blue area. So this is the border, right? Border of the car, right? So that is called edge, right? So through the filters, the edge information can be obtained. Not only edge, right? Different features can be obtained from different filters, right? So randomly, these filter values are assigned initially by the algorithm, but during the back propagation process, the weights will be updated automatically, right? So this is how the convolution happens. It is nothing but the inner product of the two matrices, simply saying, right? So everyone knows how matrix works. So if you apply inner product of inner product between the two matrices, then you will get the value. See, for example, the element wise multiplication and addition, right? So -1 into 3. So -1 is the first filter weight. So -1 into 3. Corresponding locations, corresponding cells need to be multiplied, right? So -1 into 3 plus 0 into 0 plus 1 into 1. So like that, the linear combination of weights and the input values are calculated, and we will get only one value. So that value will be replaced with the central pixel of the image region, 3 by 3, right? So in this way, the image block will be moved. The window is moved, right, to the next 3 by 3 pixel values, and the same filter will be applied to find the values, the remaining values in the output image, right? So by doing so, it tries to capture some of the essential features. So these are all some of the filters that you can apply on the input image, right? So with several filters, you can develop several layers of features maps. We call that as feature maps. So the polling layer is used to reduce the dimension of the convolution layer, right? So this is more about the convolution. Yeah, let me come to the pooling layer. So I'll come to this non-linear function later. Okay, this is a pooling layer. So pooling layer helps to reduce the size of the image into half, right? So there are two pooling layers available. One is max pooling, another one is average pooling. So in case of max pooling, one window size is identified and the maximum value within this window is taken into consideration for further analysis. For example, the window size here is set as 2 by 2, right? So there are 4 values available in the 2 by 2 window. So among 4 values, 20 is the maximum value. So it is considered, right? Rest of the values won't be considered in case of max pooling. And in case of average pooling, the average of the 4 values will be calculated and it will be utilized for the further analysis. So in this case, so instead of 4 values, right, only 1 value is considered. That's why the pooling layer reduces the size of the previous layer, right? So in this architecture, if you notice, yeah, so in each layer it is getting reduced, right? So after applying convolution, as I told that in this, right, so this summation, right, when you're finding the summation, it is called the linear combination or inner product of the input and the weight vector, right? After that, you have to apply activation function. So one such activation function is called ReLU, right? So this is a non-linear function. As per this function, right, the values will be changed, right? So f of x equal to maximum of 0 comma x. So when you are applying the filter function, there is a chance that you will get some negative values also, right? In order to nullify the negative values, right, this activation function is used, right? So as per this function, max of 0 comma x, right? If there is a negative value, then it is replaced with 0, right? So in this way, the values are converted into the given range. So by applying the convolution layer and the pooling layer repeatedly, right, we will end up with some reduced feature maps, right? So for each filter, it produces the corresponding feature maps like this, right? So after collecting the convolution ReLU, then pooling layer, so it is up to the researcher who can design the combinations of convolution and pooling layer in the way they want, right? There is no restriction on this. So several layers are applied and finally fully connected layer will give the probability value of the corresponding input image, right? So this is how the satellite images will also be processed, right? So now we have studied how the spatial data is and what are all the algorithms available in AI. We have just look at one simple algorithm, CNN algorithm. Now, how these two can be combined together to handle the disaster management, right? So multi-source data ingestion layer will be there in the input layer, through which you can collect all the spatial data and you can pre-process geo-referencing, noise removal, and you can also apply some fusion algorithms to clean the data, right? To prepare the data for next level of analysis. That is the second step. And third step, you can use AI analytics layer for prediction assessment. You can construct CNN architecture for prediction and some assessment. And GAI based visualization. After prediction, you can represent the same in the map, right? So this is how you can integrate the AI and the geospatial architecture. So using CNN, in one of the papers, I found this picture. So with landslide data patches, flood data patches, you can give it to the CNN model and the model will learn, right, the features. And during the training phase and in the testing phase, you can apply the model to classify whether the given image has some disaster or not, right? So this is how the geospatial data is combined, right, or applied to the AI models to predict something or classify something, right? So these are all some of the case studies. How the images before the disaster and how the images after the disaster, right? So these two images are given to the segmentation model, right? So through which you can easily analyze that. So these portions are not, right, completely blacked out, right, in the segmentation process, right? So through which you can identify some disaster impact index, right, to find out how much area are infected or infected with the disaster, right? So such kind of analysis can be mathematically found out, and accordingly you can do the decision making process. And similarly for forest fire detection, right, for classification, there are several UA like AI models, right? This is a kind of unit architecture, right? So unit architecture in the sense, so different layers are represented with different colors, with different numbers here, size, and the number of filters are mentioned here. And this helps to segment the fire area, right? The ultimate output is the output contains the fire regions, right? So similarly with the different architecture with the same image, how it effectively identifies the fire regions, right? So it's all about the CNN architecture, right? So different ways you can design the CNN architectures. Okay, so this is another architecture, right? So altogether, right, the AI models will enhance the accuracy of the prediction, right? More precise risk will be identified, right? And speed also, computationally, it is very quickly, it will process the data and it will lead to quicker decisions and actionable insights. It translates the complex data into a clear location specific actions for responders, and it helps to do proactive management, right? Shift focus from reaction to prediction and mitigation, right? So earlier we will be reacting to the disaster. Now we are predicting in advance, and accordingly we are preparing ourselves to safeguard. Okay, and so different case studies are given, like how flood prediction can be handled and earthquake damage in the same flow only, right? Collecting the images, pre-process the images, apply the CNN models, and finally represent the data using some visualization, right? And according to the problem, right, you can do the final or further high level analysis, cyclones, wildfires, and everything, right? So altogether it helps. AI plus geospatial analytics helps optimal evacuation routing, search and rescue planning, damage and loss mapping, and resilience planning and reconstruction, right? So there are some of the applications listed. So with this, I want to conclude the session with some challenges behind this analytics, right? So we cannot get much data. That is data scarcity, right? Labeling issues are there, right? So manually, it is very difficult to label the objects available in the satellite images, right? So that is the difficulty, and generalization across regions and disaster types, right? In different regions, the different disaster may happen, and accordingly the types need to be identified, whether it is a flood or forest fire or hurricane or what is that, tsunami, right? So this kind of types need to be identified, and real-time scalability and compute constraints. Scalability in the sense it may happen in a smaller region or it may affect the entire world like COVID, right? So accordingly, we need to have the computational capability to process the data, and at last we need to follow some ethics, right? We should not be biased, and data governance is required to secure the data, right? So with that, thank you so much for your patient listening.
Thank you, ma'am. Ma'am, is there any questions from the participants? Ma'am, there is a question in the chat box. Mallikarjun, are there any Indian platforms to gather open access geospatial data for landslide?
Yes, sir. Yes, sir. Yeah, government website you can take, sir. IMD. There are data available for research, sir.
So, is there any other questions from the participants?
So there's one more question in the chat. Like, how do we ensure reliability and accuracy of AI predictions during extreme events when the real-time data may be incomplete or noisy?
Yes, for that pre-processing is required. So without domain expert, as a AI technology himself cannot do that. So with the help of expert, they need to analyze the data. That's why I have prepared the slide in such a way that first you should do the data mining to understand the data, to ensure whether the data collected is pure, right, without any noise. Then only you should apply AI models. Otherwise, you will end up with lesser accuracy, wrong prediction. All these issues will come if the data is not prepared properly. That for that, definitely expert is required to ensure whether the data is correct or not.
Okay, any other questions? I think there is no questions. How?
There's one more question in the chat, ma'am. Like, how data collection plays an important role in the disaster management?
So without data collection, it would be very difficult to alert the people, right? So we need to collect the past occurrences of all the disaster types, and we need to identify the patterns. So by identifying the patterns, we have to analyze the continuous sequence of data that are generating now and then, right? So parallelly, for day by day analysis, we need to map with the existing pattern. Then only we can alert the people, right? So now they are doing so many analysis, that's why they are giving the red alert and yellow alert and all, with the analysis of past events only.
How will we know? Is satellite data very? Ma'am, one more question, ma'am. Is satellite data very useful for disaster mitigation? Of course.
Of course, sir, of course.
Yes, of course,
It is
yes.
also major. Satellite images are playing a major role.
We don't have no other source, no, ma'am. There is only satellite data we have. I mean, pictorial form, if you want in the picture.
Sir, SAR images are also there. Apart from satellite images, SAR images are there, and LIDAR images.
Yeah.
So many different types of images are available. Multispectral images are available. So each type of images will be used for different purpose, like vegetation, identification, flood. For different application, they will be using different types of images.
How do the temporal resolution affect the mitigation process? Based on the different satellites, we'll have different temporal resolution.
Yeah. That's why integrating all those type plays a major role. So whenever we are building a data warehouse, the integration plays a major role because the same data will be represented in different way in different sources.
Yes, so even the spatial resolution might be getting different for the different.
Different. We need to resolve that by using some mapping mechanism or transformation mechanism.
Okay. Making a baseline data is that will be the requirement for this kind of mitigation process. Is
Yes.
that,
Yeah.
So, ma'am, I think we can close the session with a vote of thanks. So, I would
Sir.
like to extend my. Sir, is there any question, sir?
Yes, sir.
Yes, please.
Madam, good evening.
Yes, sir. Please, sir.
Madam, actually what happens is whenever we have having a satellite data, we can use it for post satellite imaging. But what after the pre-disaster management, madam? Because post we can have that satellite images and we can have a very clear look at that. But pre-disaster, I think it would be very
Yeah.
difficult to
So,
analyze the exact mitigation levels and also preparedness for the disaster, madam. For
yeah,
example,
that is.
cyclones.
Uh,
We may not be able to come to a conclusion that at what speed the cyclone may hit the area, but
yes, sir. True.
that can be done only after post data. We can analyze and do all these things. But
Yeah,
pre data's information, I think disaster management, it would be a quite difficult task even in the satellite images also, madam. As I think,
yes.
but I.
Yes, sir. Yes, sir. I completely agree. That's why the challenges that I mentioned is data scarcity.
But the
Because
application
earlier,
of this AI also is also, I think, it's on a very question mark itself because AI can only predict, but it cannot exactly predict what is the amount of disaster that will occur in that area, madam. Is it true?
sir, actually, this is true. See, for example, let me take Chandrayaan 2 mission.
Yes.
Okay.
Yes.
So they have programmed well in a proper manner and they have sent the satellite, right? And what happens at last, right? With 2 kilometers, less than 2 kilometers of distance before landing, it
Yes, madam.
collapsed, right?
Yes.
So that we cannot control because of the environmental conditions, right? So
Yes.
human knowledge is limited only still, right? They try to
Yes. Yes.
extend or expand, right, to some
Okay.
extent, right? So assume that if we are storing the current data properly, then definitely it will be useful for another 10 years. Am I right or not? That you
Yes.
can
Yes. Yes,
agree.
madam. Yes,
Yeah.
madam. Yes, I
Since
definitely agree with that.
yeah, so far we are now in the AI era. Some 20 years back, right?
Yes, madam.
These kind of technologies are not available
Yes.
computationally as well as hardware and software side, both,
Yes.
right?
Yes.
So that's why they are not having the intention of storing all this data. These data may be stored in the files and records, but digitally it is
Yes.
not available for everyone, right?
Yes, madam. Yes.
So that's
Yes.
why
Yes.
started constructing spatial databases now
Okay.
for handling the future disasters.
Okay.
Yeah.
Now, madam, if the disaster occurs in a very, I mean, you know that the Arab countries are always desert places itself. Now you can
Hmm.
see rainfall even in that areas also.
Yes,
Now
of
I
course,
think
sir. Desert areas, a different kind of disasters will be there.
yes, if it is a storm affected disaster, then we can go for a preparedness of that. But if it is a rainfall affected disaster, then I think that should be under the
Yeah, that's why the pattern need to be analyzed, right?
yes,
So what causes this disaster need to be analyzed from the data. So, for
okay,
example, given one example, right? So, in one area, some disease is spreading. In order to
yes,
find the cause, right, we need to look into what are all the parameters or what are all the possible causes for the diseases. So,
okay,
by tracking the changes happening in the water pump, right? So, they analyze
yes,
because of this disease is spreading, right? So this kind of mining, that is what we call it as mining process to find the
okay,
interesting patterns. There may be some non-interesting patterns also.
yes,
So
okay,
to remove all those non-interesting patterns, and we need to look into only the interesting patterns.
Okay. Okay. Thank you, madam.
That's why before developing a prediction model, data mining need to be done.
Okay, madam.
Yeah.
Thank you, madam.
Yeah. I'm not sure whether data mining aspect is given in the previous sessions or not.
No, we don't see that.
Yeah. Okay, fine. Then
Ma'am,
this session would be definitely useful to the users.
yes. And there is a question in the chat box. One more question. What kind of skills should students focus on to work in AI and geospatial disaster management coding, remote sensing, or domain knowledge?
Majorly, they need to learn AI models. With any images, they can learn AI models with regular image processing techniques. Then they should work on with the special images like SAR or multispectral images, because those images are different. It conveys different meaning. It's not like regular images that we are capturing in our camera, right? So those images are captured in sophisticated cameras with some special characteristics. So in the initial stage, they need to learn image processing with simple CNN models, and vision transformer models are there. Nowadays, we are living in a generative AI era. So with the help of general images, they have to learn the AI model. Then they should go to the remote sensing. Then only they can understand the type of images, and they can apply the AI model accordingly.
Okay. Ma'am Gauri, ma'am.
Yes, sir. Thank you so much, ma'am, for the very insightful presentation that you have given us today. This was a little different from the earlier speakers. Like, this is a place where we learnt about the computer science background related to the geospatial technologies. Hope the participants had a good view over the AI and AI, which is related to the geospatial work. Thank you for the valuable time that you have spent along with us, ma'am. Thank you so much.
Thank you, ma'am. Thank you for inviting me as a resource person for this session. Thank you, Krishna Kumar sir.
Ma'am, thank you so much, ma'am. The level of knowledge you have taken here is very to the core, ma'am. And we have some of the participants from CSE department also, and those people are there. So it will be benefited for both the CSE as well as civil background also. Thank you so much, ma'am.
Thank you, sir. Thank you so much, ma'am.
Thank you, ma'am.
Shall I leave, sir?
Yes, ma'am. You can leave, ma'am. The participants will be feedback. So thank you.
Yeah, thank you.
The participants, please fill the feedback form before you leave.
Sir, good evening, sir.
Sir,
Sir,
good evening, sir.
Sir, tomorrow what will be the timing, sir? Since
Sir, tomorrow by 2 o'clock, the session, next session starts, sir. Session number 11 starts.
Okay, sir.
And
Okay,
it
sir.
will be ending by 7:30. And after that, we'll have a test out of 100 marks. And followed by that, the validity function, sir.
Okay, sir. Okay, sir. So test timing will be after 7:30, yeah, sir?
Test will be after 7:30, sir. Once the session is over, we'll have the test.
Okay,
And
sir.
even the test, if you don't complete the test, we'll have the link to be open for the next day also. That's not a problem.
Okay, sir.
We'll have the validatory function after that 7:30, sir.
Okay, sir. Okay, sir.
Okay.
We'll keep the messages updated in the WhatsApp group, sir.
Yes, ma'am, sure.
So I think the recording can be stopped.